Uh, Formally, the agent observes a Markov process that takes value in some complex set X, and the agent chooses a stopping rule which maps the stochastic process to one of the possible stopping times. Note that the stopping rule is predictable, which means the the stopping time should be a function of only the stochastic process before the stopping time, not after. So I cannot use information of the stochastic process after I stop. So that's what predictable means. And Q is mapping from one possible valuation to one of the possible terminal actions, which could be countable or uncountable. And the agent want to maximize some kind of utility function that's the expected value of the utility function subtracting the transfer or the price. The principal here observes nothing, and the principal chooses a mechanism which is a set of prices to incentivize the agent to choose a particular stopping rule plus a terminal action. So here, a tau q pair is implementable, means given the prices, the agent's optimal stopping rule plus terminal action would be the tau qt here. So here are three of the important utility functions. Well, one is the stopping value, which I call the large U. So this U is the highest possible utility the agent can get if she stops at time t. So the agent is basically choosing the Q that maximizes her utility subtracting the transfer. And the value function here is just the maximum of the stopping value and the expected value, the conditional expectation of the value function next period, which this object could be written explicitly as a soup of the future expected stopping values as well. So two of the interesting stopping rules include the single cutoff stopping rule, in which the agent will stop only if the valuation is larger than some value bt, which has a subscript t, means it can be different over time. And the other one is called the binary cutoff stopping rule, which the agent will stop if either her valuation is smaller than a or her valuation is larger than b. And again, they can be different over time. So to have all of them in a diagram, so the single cutoff stopping rule means on this side here, the stopping value is larger than the continuation value, so the agent will stop here, and also the agent would continue here. And similarly, the binary cutoff rule, the agent would stop here and here, and the agent would continue in the middle.